Hey everyone, it's Susan Seiler. Welcome to week 16 science experiment. You are staring at part of my granite countertop. And the reason we are doing that is we have a family friend who's a geologist and a gemologist. And when he saw my countertop, he was so excited to explain to us that the reason we see these veins running through it of the different colorings, and while they're not all blended together as one, while there are these different veins, is because each of these individual veins were like thick tubes of toothpaste. These are his words. He literally was describing it as thick tubes of toothpaste when it was formed, and they sort of layered together versus completely mixing together as, like water and watercolors would do, that they layered together in their thickness and in their toothpaste consistency. So I thought that was pretty cool that our science experiment uses that this week, and it's the exact same analogy that someone who has multiple PhDs in Earth studies used for us just this afternoon. So let's get started with the experiments. Hi, all right, now for the science experiments for this week. We have two. We have Spurt, which is the one with the toothpaste, and we have Stretch. I don't think it matters which one goes first. And make sure you read the Van Cleve section, the Y section of the Van Cleve, so you have an understanding of how Stretch specifically relates to rocks, because it talks about elastic properties within rocks and being able to withstand some amount of tension, and then after a certain point the rock will break. And then Spurt, of course, has to do with liquid magma and how that moves. And liquid magma is the consistency of toothpaste, and the movement of the magma is caused by pressure. But read that in the Van Cleves. So basically, we're going to have 4 tubes of toothpaste, and students can take turns just squeezing the toothpaste and forcing it to the top, forcing it down to the bottom, bulging it in the middle to see how that might cause a bulge. Okay, make sure those caps are screwed on tight, and of course, if a student messes around with it inappropriately, take it away. There will be enough balloons for each student to do the Stretch experiment. However, you might need some parent help of drawing on the balloon depending on the ages of your kids. So you are to draw a large square on a deflated balloon, which is definitely harder than it seems. Here we go. Okay, so draw a large square on a deflated balloon. There we go. There's a square. Divide it into 3 sections and color in the 2 outer sections. So we'll divide it into 3 sections. Really seriously, we've got to find something in the tutor meeting that will help us make this easier to do. Maybe we just need to hold it like that. Okay, there we go. And we'll divide it into 3 sections. All right, that's much better. 3. And color in this one, and then color in the second one. Having a little tension here helps the balloon, my fingers kind of curved up like this inside the curve of the balloon to give it some tension and to help it lay a little more flat to make it easier to draw. Okay, not perfect, not completely colored in, but good enough. Now we're going to inflate the balloon and observe the markings. So here we go. All right. Whoa. They really stretched out, didn't they? All right. So they stretched out. So when the tension, sorry, I am just reading this for the first time, people. I am trying to get this done today. The tension, stretching, or pull apart force, if the force is not too great, rocks with elastic properties like the balloon will recover their original shape and size when the force is removed. If the force is too strong, the rocks cannot remain together and they continue to break apart, as the balloon would break apart if you continued to inflate it with air. When there's an earthquake, the rocks in the Earth's crust are pushed apart by this force, this tension, effects of a tension force. So we can see how this balloon did not quite go back to its original shape and size. The force of tension on the balloon changed its shape, changed its size, and changed its shape. So that's it for this week. That's what we have. Hopefully in our tutor meeting we will come up with some great ways to expand upon this. And again, each student will have a balloon and there'll be enough for guests, should we have guests this week. But you'll need some parent help in drawing those squares on there. And of course we can't reuse balloons because that would be nasty. All right, so that's it this week. God bless you, and I will see you on Friday.